Okay, right now we will be trying to solve another flow problem. This is uh, usually called as a three reservoir problems. Ganun pa din naman ito, para pa rin siyang application ng pipes in series and parallel pipes and in series pipes. Then minsan pinapasukan na rin siya ng pumps and turbines na principle. So pare-parehas lang naman ng konsepto, nagkakaroon lang ng syempre combination nung mga iba't iba nating natutunan ng mga nakaraang lessons. So itong particular na problem na to, ito yung isang klase ng problem kung saan identified lahat ng direction of flows. Sa susunod na video, ipapakita naman natin kung paano naman i-solve yung kapag may hindi known, no, or may missing na direction of flow. So let's try this. So ito yung from the book naman ni Ruben de la Fuente na book, reference text in hydraulics. So this is the problem. The turbine shown in figure L is located in the 35 cm line. If the turbine efficiency is 90%, determine the output power. Okay. Then, tingnan natin yung figure. So, ayan nga, meron nga tayong tatlong reservoir A, reservoir B, reservoir C. Then, connected sila ng pipe 1, pipe 2, pipe 2, then pipe 3. Then, sa pipe 1, along pipe 1, merong turbine. So, given din yung mga elevation ng water surfaces sa bawat reservoir. So, meron tayo elevation 400, 330, 280 for ABC respectively. Okay. First, establish natin yung mga working equations natin. Katulad ng for parallel flows, alam natin na dahil given naman din yung direction ng flow, so we have Q1 is equal to Q2 plus Q3, no? Pinapakita na yung Q1 dumaan sa turbine, tapos pumunta sa pipe 3 tsaka sa pipe 2 pupunta sa reservoir B and C. Okay? So yun yung isa nating alam. Pangalawa, alam natin na yung head loss from 1 to 3 from A to C, HF from A to C is equal to HF1 plus HF2 plus HF3, no? Kaya magagamit natin to sa pag ginamit na natin yung Bernoulli energy equation. So meron tayong HF1 plus HF3. So basta alam natin din na meron tayong turbine along pipe 1. Okay? So yan. So yung ganitong problem, applicable pa rin sa Bernoulli energy equation. So depende na lang sa'yo kung paano mo gagawin. So ang hinahanap nga pala sa atin is output power. Mamaya explain natin kung ano ibig sabihin ng output power. Okay. So, sulat natin, mag-start tayo sa Bernoulli energy equation from from reservoir A to reservoir B. So that will be BA squared over 2G plus PA over gamma plus ZA minus, unahin na natin yung friction loss na HF1 plus HF1 minus HF2, tapos yung energy input to the turbine, so ET, so wala pa ET, ayan, tawag natin, is equal to BB squared over 2G plus PB over gamma plus ZB. Okay. So ngayon, katulad ng usual na process natin, identify natin ngayon kung alin yung mga negligible, yung mga zeros, yung mga pwedeng eliminate ng mga values. Okay, so for VA squared, alam na natin that this is negligible for the same reason. PA is also negligible, 0, sorry, kasi exposed. Then ZA, alam natin na ito ay 400 meters. Ang assumption natin is that ang datum is nasa elevation 0. And HF1, may makukuha natin siya. HF2, makukuha natin. And si ET, masosolve natin. Tapos, si BB squared is negligible. PB is 0. And CB is 330. So, pag sinimplify natin yan, so, ang tira sa atin is 400 minus HF1 minus HF2 minus ET is equal to 0. Is equal to 330 meters. So, simplify pa natin, lagay natin lahat ng known sa kabila. Tapos, i-multiply natin sa negative 1. Or, hindi, ito na lang. Lahat ng negative, lagyan sa kabila. Tapos, ito dito. That will give us 70 is equal to HF1 plus HF2 minus plus ET. Okay? So, isa na itong working equation. Ito pala ay HF2. Ngayon, try naman natin. Same dito, then papunta naman tayo sa Q3. So, VA squared over 2G plus PA over gamma plus ZA minus HF1 minus HF3 minus ET is equal to B C squared over 2G plus PB over gamma plus ZB. Ay, CB. CC pala. CC. PC and CZ. ZC. Yan. ZC. So, ganun ulit. Alam na natin to negligible yan. Ito 0. Ito 400. Ito may masosolve natin. Then si VC is negli ulit. Si PC is 0. Then ZZ is equal to 280 meters. So, pag sinimplify ulit natin, meron tayong didiretso ko na 210 is equal to HF1 plus HF3 minus plus ET energy input to the turbine. So which among the unknowns that we again, so among the unknowns, HF1, HF2, ET, HF1, HF3, HF3, which values can we directly compute na? No? So meron tayong given na value for Q3. So pag ginamit natin yung formula na HF is equal to 0.083 FL Q squared over D raised to P. So meron naman tayong meron tayong Q, meron tayong L, meron tayong F, meron tayong D. So masosolve natin si HF3. Tama? So try natin i-solve si HF3. Yan. So HF3 is equal to 0.083 F3 is 0.02. Then L L3 is 2,440. 2,440 meters. And then Q squared is 230 liters per second. So huwag kalimutan i-convert sa cubic meter per second. So that will give us 0.23 cubic meter per second. Yun na yan, Q squared. And then ang denominator niya is d raised to 5, which is to 30 centimeters or 0.3 meters raised to 5. So masasolve natin sa HF3, which is equal to 0.083 times 0.02 times 2440 times 0.23 over 0.3 raised to 5. Nakalimutan natin yung square. That will give us HF3 equal to 88.175 meters. Ship store A. Bigyan natin siya sa A. So, pwede na siyang balikan mamaya. So, meron na tayong HF3. Ano naman kung meron na tayong HF3? May iba pa ba tayo masasolve after natin siyang ma-eliminate? Anong pwede natin gawin? So, may napansin lang ako, mali pala ako dito, no? Itong 400 minus 280 is na 210. Ano ba yan? Buo po naman sa math na ito. Ayan, compute na natin. 400 minus 280 is 120. Ayan. Gumana yung dyslexia. Ayan. So, yun. So, move on tayo sa next part nung solution. So, if that is 120 and this is 70, na-solve na natin sa HF3. Then, ano pang masasolve natin? Parang wala na, di ba? So, pero pwede natin gamitin itong diskarte na to. Tinuro to sa algebra naman sa inyo siguro. So, kunin natin sa equation 1 tsaka sa equation 2. That will be 70 minus HF1 plus, is equal to HF1 plus HF2 plus energy input to the turbine. Then, 120 is equal to HF1 plus HF3 plus ET. Ang gagawin natin dyan, subtract natin ng buong equation. Ninegate natin siya and then pagkasamahin natin sila. Okay? So, para lang tayo nagkaroon ng 70 minus 120. That will give us negative 50 is equal to HF1 will be cancelled. No? Magiging 0. HF1 minus HF1. Then, ang matitira rito is HF2 minus HF3. And the turbine and the ET will also be cancelled. So, alam na natin yung value ni HF3 which is 88.175. Ayan, 88.175 meters. So, we can say already that HF2 is equal to ayan. So, negative 88.175 transfer natin doon magiging additive. So, 88 yung alpha A natin minus 50. So, HF2 will be 38.175 meters. Store natin sa D. Store D. Ayan. Since meron na tayong HF2, pwede na nating masolve si Q2. No? Pag nasolve na natin si Q2, masasolve na natin si Q1. Anong gagamitin natin yung formula? So, yun pa rin yung formula for HF. HF2 is equal to 0.083 FL2 Q2 squared over D2 raised to 5. So, solve natin. HF2 is already 38.175. is equal to 0.083. F2, sorry, F2 yan. F2 is, balikan natin to. F2 is 0.024. 0.024. Length 2 is equal to 610 meters. 610 meters. Then Q2, yung unknown natin, Q2 squared over D2 to the fifth. D2 is 15 centimeters or 0.15 meters to the fifth. So kapag dinivide natin, makukuha natin si Q2, no? I-divide natin si 38.75, then multiply natin kay 0.15 raised to fifth. So that will have, this is B, no? This is B times 0.15. Lagyan natin diretso. Alpha B. Sorry, alpha B. Alpha B times 0.15 raised to 5 over 0.083 times 0.024 times 610 will give us, hindi pa yan naka-square root, square root pa natin yan, 0.0488 439 cubic meters per second, or Q2 is equal to minus 1,000 para maging liters is 48.843 8439, sorry, liters per second. Okay, so since alam na natin si Q2, divide ko siya sa 1,000 kasi yun yung i-store ko. Store C, store ko to kay C. So alam na natin si Q2, so pwede natin ma-solve si Q1. Q1 is equal to Q2 plus Q3. Then that will give us Q1 is equal to 48.8439. Ay, sorry. Ito, 0.0488 cubic meter per second plus Q3 na 230 or 0.23 cubic meter per second. Then Q1 will be equal to times plus 0.23, 0.27884 cubic meter per second. Siya na si Q1. So ano naman kung nasolve na natin si Q1, hindi pa rin natin nasosolve. Ang hinahanap pa naman sa atin is yung efficiency na at 90 degrees. Okay. Kapag nakuha natin si Q1, gagamitin natin siya para ma-solve si HF1. Kasi si HF1 is involved dito sa energy equation na ito. Tama? So, pag nakuha natin yon, yan, pwede na natin ma-solve si ET. Baga, ang pinagmulan kasi nung itong dalawa na itong equation 1 and equation 2 natin, kailangan si HF1. Okay. So, let's solve for HF1. So, gagamitin ulit natin itong formula pa rin na ito. So, papalitan lang natin siya ng papalitan lang natin siya ng HF1. So, HF1 is equal to 0.083 F1 L1 Q1 squared over D1 raised to 5. So HF1 is now equal to 0.083 times F1. F1 is 0.018. Then the length 1 is 1,220 meters. Then Q1 is ito, 0.2788 to the 4. Hindi ko pala ito na store, shift stored. Ito na yung D. Ito si D. Squared over D raised to 5. D raised to 5 is 35 centimeters or 0.35 meters raised to 5. Yeah. So h of 1 is now equal to 0.083 times 0.018 times 1,220 times alpha D, which is 0.27884 squared over 0.35 raised to 5. That gives us an HF1 equal to 26.9831 meters. HF1. Store natin siya sa E. Shift store E. So kung alam natin si HF1, so pwede natin gamitin sa equation 1 or sa equation 2 to solve for ET. So 70, gamitin natin si equation 1. 70 HF1 is 26.9831 plus HF2 is 38.175 meters. Then CET. So ang matitira ngayon is equal to 20, in 38 is B, 26 is E. So that will be 70 minus 26, which is letter E, alpha E, minus 38.175, which is letter B. So, ang natira sa atin is 4.84149 meters. Yan ang energy input to the pump, to the turbine. So yun yung tinatanggal niya sa system. Malit lang, di ba? So ang tanong sa atin, balikan natin yung tanong sa atin. Ayan, balikan natin. So the turbine shown in figure L is located in 35 cm line. If the turbine efficiency is 90%, determine the output power. Output power yung tinatanong. Okay. So yung power, ang formula ng power is equal to Q gamma E. Tama? So for this case, ang hanap natin is output power. So PO is equal to Q1 kasi nasa pipe 1 siya, then E T times yung efficiency niya na 90% or 0.90. Okay? Output to, kaya meron na tayong ina-apply na efficiency. So PO will be equal to Q1. Ano ba yung Q1? 0.27884 cubic meter per second. ET is 4.84149 meters. And then ET is nawala pala yung gamma. Gamma is 9.81 kilonewton per cubic meter. Then the efficiency is 0.90. Then PO is equal to there's F. Alpha F. Yan. Alpha D is Q1 times alpha F times efficiency times 9.81. So the power output is 11.919 kilowatts. Yan. So ganun lang siya kasimple. Medyo mahaba lang pero nakita nyo naman pare-parehas na principles yung ating ginamit. No? Medyo na baka gumamit lang tayo ng konting algebra para meron tayong ma-eliminate, pero definitely everything is common and paulit-ulit lang. So I think kayang-kaya nyo na yung ganitong klase ng 3 reservoir problem. So thank you for watching. Proceed tayo sa next example.